My name is Keqiu. I'm going to talk about 3x3, reliable, fast, and stable mobile continuous delivery today. So first, who am I? I'm an engineer from LinkedIn or like Microsoft. But we are still working on iOS apps and Android apps, and we are building like great iOS and Android apps still. For me, I'm primarily working on the mobile infrastructure. Okay. So I'm working on the mobile infrastructure team at LinkedIn, and I'm primarily driving the 3x3 initiative to bring our mobile developers the best continuous delivery experience. So here's a brief agenda for today. So I will first give you some background for our project 3x3, and also like what is 3x3, and how did we accomplish 3x3, and also the next steps. So firstly, let me give you some background. So last year at LinkedIn, we conducted a project called Voyager that is basically overhaul our previous old flagship application and to build our new ones. And we took this chance of rewrite to invest a lot in our mobile infrastructure at LinkedIn. And 3x3 is a major initiative to make our delivery much faster and better. And for scale, we have around 120 plus people working across the iOS and Android. At such a scale, it's really hard to have a stable and also fast continuous delivery. If it's only 6 people or 5 people, it's very easy to tap on the other guy's shoulder and say, hey guys, you screw up about chunk, please fix it. But at the scale of 100 plus people, it's super hard. And that is the question, and that's the problem we want to resolve. So what is 3x3? The first 3 stands for we release 3 times a day. And also the second 3 stands for the commit to publish time should be less than 3 hours. This sounds super simple, right? But it's actually much harder to do than to say. So, because we invested a lot in 3x3, there was some moments like our engineers and also some leads even threatened to leave the company because we invested too much in 3x3. And the result is they imagine if we keep investing so much in 3x3, it's not possible for us to deliver our product in time. So the good news is we still held fast on our 3x3 goal. And during one discussion, our engineering VP just put his badge on the table and said, if we don't deliver 3x3, we won't deliver our app. So why is 3x3 so important? And why does our engineering VP even want to risk his job to deliver this task? So let's say what is before 3x3. So before 3x3, we release our mobile app once per month. That is greatly limited by our testing regression cycle. So it's unlike our backend services, you could easily roll back to an older version, if you found any bugs in your newer release. But for mobile apps, we cannot. So it's once you uploaded your app to the App Store, and once the user downloaded the app in their phones, it's not possible for us to go to each individual user and ask them to give us their phones and uninstall the previous version to install a fixed version. So we had to be extremely cautious about our app release. So normally we have a fixed date every month, and before that date, and 10 days before that, we would spend 2 or 3 days to have some bug bash. So that is basically the whole mobile team stopped working on features, but focusing on debugging and also fix and trying with our apps and try to find any bugs. And after 2 to 3 days bug bash, we hand our build to some offshore team to run 7-day manual testing regression cycle. So in the end, we can only release once per month. But the actual case is even worse, because as I mentioned, there will be a 10-day regression cycle, but if we found any bug in our regression cycle, we would have to submit a hard fix to our release branch. And the possibility is we don't know whether there will be new bugs in our hard fix or not. So we would have to run our regression cycle again and again until it passes. And one more thing is it's in the college days. So if tomorrow is not a due date, today is not a due date. So it's like every month, right before the due date, everyone will rush in commits. Like for example, normally on every day there'll be only like 10 to 20 commits, but by the due date there'll be like 100 or like 200 commits to our repo, and that is crazy. And if people want to rush in code, the quality cannot be high. So it's very likely for us to see regression bugs in our regression cycle, and so we have to submit some hard fix to our branch. So the actual release cadence is even fewer than one release per month. So every year we only have around like eight to 9 releases every year. And the result of this is our product team would have to plan their features and release like carefully, because we only have 8 releases. If they skipped one or like they missed one, they would have to wait for 2 months. So the iteration would be super low, and you cannot like try a lot of things. So what about 3x3? So with 3x3, we want a consistently high throughput pipeline, and we want low latency, which means almost zero reflection for the code for our dev box to the production. And also we want to commit to publish time less than 3 hours. This means every step from commit to publish should be fast and also automated. And also, if we are trying to deploy in 3 times a day, in the same time, we have to ensure that our pipeline must be always stable. So there will be no surprise. For example, in the release day, you found some tooling bugs and you cannot release. You have to wait for another 1 week. So it will also fix this. It will also ensure this will not exist. So what are the challenges? Why is it so hard? Like we spent the last whole year investing like so much in our pipeline. So what are the challenges? So there are basically 3 challenges: reliability, speed, and stability. All of them are super important. Let's talk about the reliability first. So to accomplish 3x3, we want our pipeline to be super fast. But it doesn't make sense for us to like sacrifice our product quality just to speed our pipeline. So we have to spend a lot of time to make our pipeline also reliable, which means like every commit that can pass our build pipeline should also have production quality, which means the user can use any of the build from our pipeline. So in order to achieve a high reliability, we also use this testing pyramid. So the major parts are unit test. Then we also have layout test, scenario test, and also a small portion of a layout test. So for unit test, this is just a common unit test. For our mobile apps, we have around 3,000 unit tests to cover most of our logics, and also some of the major infrastructure code. But only have unit test is far from enough for sure, because for our mobile apps, most times are like user facing. It's not like endpoints for the server side. So we also need to test our views. So we introduced some test category called layout test. This is a bit like the unit test for our views. So with our layout test strategy, we can stress test our views. So we can like plug in different kinds of strings, for example, like long strings, short strings, or empty strings to our views. And in the same time, we can make sure there's no overlaps between our views, and also the view will not be like rendered out of screen. And also with this framework, we can also test like from right to left, also should be working correctly. Again, so only have layout test is also not enough. We have scenario test. So as I mentioned before, we have like 1 week long manual testing to testing some functionalities. So why can't we just automate this? If you think about the manual testing, it's more like some QA tester, they will open our app and tap on some button to navigate around, and then type in some string, and then do some assertions. And all of this should be and could be automated. That is our scenario tests. So we did some research and put in some like libraries to support this kind of scenario tests. So for our iOS, we use Keqiu, and for Android, we adopted Google's Espresso. And with those frameworks, they can help us automate all these actions. For example, tap on buttons, or wait for a view, or like and some strings, and also we can do some assertions. So with this, basically kind of like eliminate any kind of necessity for our manual testing. So the next step is dogfooding. So maybe you will say like only have automation is not really fast enough. There can still be some edge cases that can only be tested by human beings. And so we have some dogfooding. So remember, like for example, if you submit an app to App Store, it will take Apple 1 week to review our app. So we leverage that period of time to do some dogfooding. So every time when we submit a beta build to App Store for review, and we are also push this build to our internal employees. So if you log in with our employees account, if you open our production build or if you open our old beta build, you will be promoted with like splash screen like this one. So this one will like enforce you to go to our latest beta build and try that around. So this greatly improved our active users for our beta build. And in the same time, we can also like monitoring. Yes. Yes, that is latest. Previously it's like 7 days or 14 days. Right now it's around 2 days. Yes. So we want to leverage this period to do some dogfooding. Yeah. So and also in the meantime, we are also do some like monitoring the crashes and also monitoring the metrics to make sure nothing is broken here. And maybe you can see like shit can still happens if we roll out this one to production. And to resolve this problem, we want to take advantage of our LinkedIn A/B testing framework. So one major feature in 3x3 is to put everything behind lakes. So whenever we want to like roll out some new features or like new code or like refactoring, we want developers to put them behind the A/B test. So with this, we can say if we still see any errors like in our code, like when we push production, or if we see any like production, like product side issues, for example, if we change the color of our icon from blue to green and no one is using our app anymore, we can always turn this off in the server side. So it's like if we ever found any issues with our app, we can just turn off the new feature like from our server side. And with this automation coverage and also with this dogfooding and also with leaks, we pretty much have like 99.9% confidence that our production build application should be stable and also have a high quality. And yeah. So after talking about reliability, the next part is our speed, which is also a major part of 3x3. We want to speed up our delivery time. So previously, it's like take 10 days to release one build, to certify a build. But we want to speed it up. We want our commit to publish time less than 3 hours. So how did we do this? So the first part is to speed up our compiling time. So previously, because we started our project with Swift in a even very early stage, like in 1.0, and during that time, the compiler is not in a like mature shape. But we already adopted that. And as we wrote more and more code, we found the compiling time like increments exponentially. So during like last year, like similar time, maybe July or June, the release bandwidth time took us like 2.5 hours to compile one single bandwidth files. So it's not, and also for local build, it took us like 40 minutes, which means if you modify some like lower level files, for example, in the project file, or modify some shared library files, you would have to recompile the whole thing for 40 minutes. It's like if you added one line, you would have to wait for 40 minutes to compile it. So what we did is to firstly try to research from like Stack Overflow, like copying and pasting from Stack Overflow and try to find some resolutions. But however, there's no luck. Let me turn to like Apple forums and trying to search for some help. But however, because we cannot like share any source code like in any public forums, we cannot get too much help. So what in the end is like we send them some emails, like send some emails to Chris Latner, send to them engineers and asking for them help. To our surprise, they responded to us and help us, give us a lot of suggestions. So one key suggestion is to lay out our code base. So previously, we have like one single monolithic code base. So this suggestion is like divide them into multiple layers and also divide to multiple modules. And we did that, and that reduced our compiling time from 2.5 hours to only around half an hour. And for local debug build, it was around 40 minutes. After this refactor, it became only 15 minutes. But you may say that 15 minutes is still too long for us. Can we still optimize that? And that is our last resort, is to buy more hardware. So in the end, we bought every iOS developer 12-core Mac Pro, and that greatly improved the speed from like 15 minutes to only 5 minutes. So after talking about the compiling speed, the next part is the testing speed. So when we start writing tests, we have like gradually write to around like 200 tests. For only around 200 scenario tests, that already took us like 2.5 hours to run them like in sequential. That is not tolerable because we need to run 2.5 hours before we know what our code is legit or not. So what we did is also like speed up our testing frameworks. The good news is for most of the Apple stuff, they are like closed sourced, but we are using some open source library for our testing framework, which is Keqiu. So we forked out the Keqiu framework into our in-house repo and did a lot of refactoring and also some surgery on the Keqiu. And the end result is make it like 10 times faster. And you can see from the GIF, the left one is before our surgery and the right one is after our surgery. So it's like around 10 times faster. So this reduced our testing time from like 2.5 hours to only around 20 minutes. But however, that is only for 200 tests. And we want our build to be fully relied on our testing framework, to our automation testing. So we want our developers to write a test in the same time when they are writing new features. It's like concurrently. So the number of tests in our test suite gradually increased from like only 200 tests to like 2,000 tests, and that brought our overall testing time to around 2.5 hours again after a few months. So if there's no much space we can optimize for our compiler, and also there's no much space for us to optimize our framework, the next one we can do is to have a distributed build and testing. So instead of doing everything in one single machine, like for example, doing build first, then do some test, then do some release build, why can't we just distribute them out into multiple machines? So we spent some time, like 1 month, to investigate on this, and in the end, we brought out such a system. So we are like build one release build in one machine, then divide our testing targets into 10 different test bundles, and then distribute them out into 10 different nodes. So it will be like 1 node for release and 10 nodes for testing, and that greatly reduced the time from previously 2 hours to only like 30 minutes, which is like bottlenecked by the compiler. The next one is stability. So as I mentioned before, we like fully rely on our automation testing. So if any of the build or any of the commit failed to pass our pipeline, we are simply rejected. So which means if there's any flakiness in our pipeline, and for a legit commit, it can be like rejected for some flakiness in our pipeline. So this really matters to us. And we were in some time like our pipeline is only like 10% stable, which means if you have legit commits, if you commit 10 times, only 1 time it will pass. That introduces a lot of developer unhappiness. So we want to improve on that one. So I will talk about like how we improve our stability from only like 10% to in the end like around 95%. So there are 2 parts for stability. The first part is our testing infrastructure stability, and the second part is our tooling stability. And for the first part, it's more like the software side. How can we improve our software to make it much more stable? Second part is more like hardware part. How did we make our hardware more stable, more resilient? Let's see the first part. So the first thing is how did we stabilize our testing environment? So in our old testing paradigm, we want to test like end to end. So for one test in client side, it will have to talk to the front-end server and then talk to the back-end server. So there are multiple dependencies. One is depend on the networking. So because there are 2 round trips for network request. And if network is broken during our test run, our test will fail. And we also depend on the front-end server and the back-end server. If there is any flakiness in front-end server or back-end server, our test will also fail. And it's not possible for us to know whether the problem is in our testing, in our client code, or whether it's in our server code. So we also have some idea. So we brought the idea of hermetic testing. So instead of like doing end-to-end testing, we do some hermetic testing. So instead of talking to the real servers, we have some fixture servers sit side by side with our app. So when there's a request from client side, it will be intercepted by our fixture server. So fixture server will be based on previously recorded or like handcrafted response and respond to the server and respond to the client side. And this made our client side test much more stable, much more, and also much faster because there is no network delay for our test. The next one is to stabilize our testing frameworks. And because we are using some open source libraries for iOS, which is Keqiu, and also using Espresso for Android. But they are also like in a pretty early stage. It's not and they are not designed for kind of like enterprise usages. So we found some like flaky APIs in the testing frameworks. So what we did is also like just fork the open source one and did some changes to the library. For example, like added some reliable weight. So previously, for example, you can see I will navigate from page A to page B. Let me do some validation. And wait for 1 second, and then we'll do some validation. But it's possible, like in some slow machines, page B will be rendered fully, like in 2 seconds. If you validate the view like before that, maybe the view is incomplete, and the value may be not updated. So that will introduce some fake news. So we added some reliable wait, which means we will be waiting for the view to be fully rendered before doing validation. And that greatly improved our stability from only like around 50% to around 80%. The next one is fix some unreliable APIs, because there are some hard-coded like time wait in the framework. So we also remove that part. And the next part is also very interesting, is how do we sanitize our test suite. So right now, suppose we have a 100% stable testing environment, and also 100% stable testing framework. But the developers can still abuse that. For example, our developers can like forget to add some checkpoints, add some reliable wait. They will still like manually wait for like a hard-coded time, or they can like expose some different API to use to write some test. So how did we sanitize the test suite? Let's do some math first. So what is 99.9% to the power of 1,000? Any answer? You want to guess? Yeah. You want to choose one? Choose one for them? 99? The result is only 36.7%. It's astonishingly low. So this means if we have 1,000 tests and each test only have a 99.9% stability, our overall test suite will still have only 36.7% stability. And we want to equal our test quality to our production quality. So suppose if you open like our LinkedIn app, it would crash like 2 or 3 times. No one would use it, right? And that's the same case for our test suite. So if you run our tests like 3 times and 2 times will just fail like randomly, no one will give a shit about our test suite. People will just say it's not caused by our commit. It's caused by the flakiness in our test pipeline. So and also they will completely lost the confidence in our test. And also, because we will reject any commit that failed our pipeline, so that would introduce a lot of developer unhappiness. And the most important thing is we reload tests primarily to prevent regression, not to block our development. So our final conclusion is flaky tests are even worse than no tests. So we would rather write no test if the tests are flaky. So based on this conclusion, we wrote some service called Chunk Guardian. So Chunk Guardian is some intelligence service that will keep running the existing code against the previous green build. And if any test passed before but failed later in some green build, we will disable that. And with this one, we improved our Android chunk from previously 80% stable to around 95% stable. And from iOS, we improved from 80% to around 90%. Okay, so next part is the tooling stability. So our tools is also quite naughty. It's like this little go here, and it can be even naughtier. So this includes also three parts: the hardware stability problem, and the build environment stability, and also the distributed testing stability. So in our machine pool, we also we often saw these kind of scenarios. Some nodes are completely corrupted, and if any jobs landed on these nodes, they will be failing for no reason, for some tooling reasons. And what we can do is only to contact our tooling partners, say this node maybe is completely busted. Could you please help us disconnect the node, so we can bring us back to a green state? But that cannot scale because we have 400 Mac Minis for our iOS building pipeline, and also more than 400 nodes for our Android building pipeline. So what we can do is to build some other services to make sure our pool will always be stable. And that is the second guardian for our build. That is a pool guardian. So pool guardian is like the safeguard, sitting next to the swimming pool, taking care of every swimmers. And every swimmer is every machine in our node, every machine in our pool. So what pool guardian did is it will actively search the pool and try to find if any node failed the health check. And also it will also passively remedy the problems in a pool. So for example, if a build failed, the pool guardian will come in and do some health check to check whether it's caused by tooling failures or whether it's caused by test failures. If it is caused by tooling failures, it will pull the node offline automatically and also do some remediation. The next one is the distributed testing stability. So previously, in order to speed up our testing speed, we introduced this kind of distributed testing stability. So we are divided one testing bundle into 10 different targets and distribute them out to 10 machines. But however, there are some stability problem with this. So suppose each node has a reliability of 95%, but if we want one job to pass, it must pass in all 10 nodes. So we have to multiply the 95% by 10 times, and that is only 60%. So even the commits are legit and the tests are fully stable, but if our machines only have a 95% stability, we only have 60% stability for our overall pipeline. So what we can do, the first thing we did is to just improve our average reliability of each node. For example, build some pool guardian and also have some better health check mechanisms, and that helped us from moving from 95% of stability to 98%. But however, that is still not good enough. So if you multiply 98% 10 times, that is only have 82%. And we want something beyond 90% or even beyond 95%. So what can we do? So we have to think out of the box. So instead of distributing them out to 10 different nodes, and each node will run one simulator, why can't we just collapse them into one node and run multiple simulators in parallel? So that is what we did for iOS, both Android and iOS. So previously, we are distributing them out, for example, one job to one node, and the node will bootstrap one simulator and run tests and return back the results. So right now, we run 10 simulators in one machine. And distribute one and distribute the test target into 10 simulators. So they would be able to run the tests in parallel. And this solved the problem of the distributed build testing and finish the last step of our stability improvements. So this improved for iOS from around 85% stable to the final 95%. So this is the result. So like by early this year, there was some upgrade for iOS, and our stability dropped to only around even like 0%, which means no commits can go through our pipeline. And after our procedures test, for example the stabilizing from our testing infrastructure and also our tooling side, and also the distributed build testing stabilizer, it increased gradually from 0% to 95%. And yeah, that's it. So, and for the next steps, we are trying to even stabilize our machine pool and also make our pool more stable. And here, and we also have a lot of posts about our effort to stabilize and also make it faster for our mobile delivery. Yep. Any questions? Yeah. Yeah, that's a good question. So all these things are powered by Gradle. So we use Gradle for dependencies for example our Cocoa Pod dependencies for iOS, and also it's built in for Android for all kinds of dependencies. That is kind of like everything here is like empowered by our Gradle. For example, how do we run tests? There'll be a lot of hooks between different targets. Like for example, before you test run, we'll do some cleanups and do some health checks. And after build, we also do some health checks. They're all powered by Gradle. We have internal repo for the for the open source libraries. So we are pull them into our repo, and we publish our dependencies into like a dependency map to our artifact, and by that and that will determine like the dependency graph between different Cocoa Pods. Yes. There was a talk from Yarek last year. There was a talk about from Yarek, I think 2 years ago, about this. You can check that out. Any more questions? One build, one machine. Yes. Not VM, just in the OS. Yes. So we have some checks. For example, after each build, we'll do some cleanups. So right now we still don't have like 100% violation, like isolation between different builds. But we do some health checks and also removing and kill the previous jobs and do some cleanups. Yeah. So we are not using VM yet, but we are considering trying to use some VM. Yeah, in the future. Yeah. You mean device lab? No, not yet. We don't have device lab yet, because that is, we were planning to have such a device lab for some live testing, but for our pipeline, it's not fast enough. It's not fast enough, and also the devices are not as stable. So we didn't use that. We didn't plug that into our pipeline. Yes. Yes. So Chunk Guardian is a service that only disable tests. So the like how to re-enable them is pushed by our testing team. So for Chunk Guardian, it's only, for example, if a build passed our test, right? The previous test should all have passed. The Chunk Guardian will run the same test suite against the same build again and again. And if it found any like flakiness in one test, if the test ever failed, it will just disable it. And the procedure to re-enable them is pushed by our testing team. So our test engineer will like try to find the problem, like why it's flaky, and work with our engineers to re-enable it. And, so we did uh, so there are two parts, right? One is the testing stability, and the other part is tooling stability. We don't disable tests based on if it failed for tooling reasons. That is baked into the Chunk Guardian. And if it failed in the test side, we did some like stress testing for our testing frameworks. So we were running the same test with the same testing framework version for 1 week, and we didn't find any like problem with our test with our framework. So we have pretty much have like 100% confidence in our testing framework. So if Chunk Guardian disable any like fake test, it must be some problem with the test. So we would have to fix it. Yeah. Any more problems? Can you repeat that question? Yeah, it's all Gradle plugins. For example, the multiple similar runs, they are all written in Gradle in Groovy, in our code base, and they plugged into our building pipeline. So in our pipeline, we will do like our Gradle like like an install pod for the iOS build, and then we do some testing, and then we do some cleanups. It's all like hooked into a Gradle pipeline. Yeah. They just use regular Xcode. So Gradle is only for the building pipeline, like how to chain all of them together, like build tests, cleanups, or etc. The pipeline is built by Gradle, but most of the code for developers, they only using Xcode.
How do you handle like the common thing that developers come to like start engineering things and say, oh, this is working on my machine.
Yes. So for example, like one thing is the like a Cocoa pod. So that can be different versions between developer environment and also the environment in the box. So we are trying to like set up some local environment. For example, use RVM to set up some different Ruby versions and download the corresponding like Cocoa pods into that virtual environment and run from there. So it's like we are trying to make it more consistent, but yeah, it's not ideal yet. Yeah. Any more questions? Cool. That's it.